Hello everybody, and welcome back to the Poor Man's Chemist. In this video, we are going to be making gold 3 hydroxide using the potassium tetrachloroaurate focus that I made in the last video. Now, as I came to find out when I went back and I checked, this is actually potassium tetrachloroaurate hemihydrate, meaning that for every unit of potassium tetrachloroaurate, there's half a molecule of water. Of course, that isn't really how it is. It just means there's 1 molecule of water for every 2 units of potassium tetrachloroaurate. Anyways, I dried these crystals out over low heat. It was about 70 degrees C on average. It ranged from about 65 to about 85. I made sure it didn't go any higher than that. And I got these beautiful free-flowing crystals. There is 0.4 grams of this stuff, which corresponds to I know in the community post I said 40, but that was before I realized it was the hemihydrate. So actually it's like 39% and change. Not fantastic, but since all of the gold that didn't end up in these was recycled, it's not really a big deal. So what we are going to do, we're going to improvise this a little bit. The handbook of preparative and organic chemistry says to do this over a water bath. We're just going to keep the heat very low and hope that that works. Because I live in a rainforest, there is water dripping down from the trees. It rains every fucking night. Anyway, here we go. We are going to dissolve this in a small amount of water. It should be very water soluble. There we go. Get that very nice. Zoom it a little bit so you guys can see that a little better. You can see it freely dissolves in water, makes a beautiful yellow solution. Isn't that pretty? Alright. Is that all of it? What the hell is that? Oh. I don't know what that is. Oh well. Anyway. Some kind of water on the bottom of the beaker. Anywho, who cares? Now, we are going to add slight excess of 3 molar equivalents of sodium carbonate solution. See there? Alright. Rinse that out and add it in here. Okay. And now it says to, like I said, the textbook says to heat it over a water bath at this point. I'm just going to keep the heat low, about at the same point that I dried the potassium tetrachloroaurate at. It'll be about 70 C. That should be good, I think. I don't know. We'll see. I've never made this compound before, and I've never seen it before, so it'll be a learning experience for all of us. Okay, everybody, this has been stirring here on the heat for about 30 minutes. I switched it over to the other crappy hot plate because the heat on this never really gets much higher above boiling, but it wasn't doing much on the other hot plate at about 60 degrees C. So it's on here. I'm keeping an eye on it. The textbook said this would take several hours, so I didn't think to try to get a time lapse of it, but this has only been going, at a decent temperature now. Maybe, how hot is it? I don't know. It's good and warm. It took a second or two before it started to burn. It's under 100, above 50. It's somewhere in that range. Yes, I could check if I really wanted to, but I really just wanted to show you guys, I guess when it starts working, this is what it looks like. It's pretty cool. And again, I have no idea how long to let this go for, because the textbook just says several hours. What does that mean? So, we're just going to let it stir and go, and I'll keep reporting changes as they happen. Well, it didn't take hours. It took about 1 hour. For the stuff to change from that, I don't know, that kind of almost orangey color to this. It's a brownish powder, exactly like it's supposed to be. I think this is it. That went a lot easier than I thought it was going to. So I'm thinking maybe what I'll do is very carefully remove the liquid from this, rinse the gold 3 hydroxide well, and then go ahead and try to turn it into potassium aurate. Since I've never seen where anybody has ever done that before, I've never seen an aurate salt. It could be cool to look at. So we'll do that. I will, like I said, I'm going to remove the solution here. I'm going to rinse this a few times. And then I will come back when we are ready to try another reaction with this. Alright everyone, so here is our gold hydroxide. We don't have a whole lot of it. Of course I haven't been able to weigh it because it hasn't been dry at any point. But we're going to go ahead and assume that it is the same number of moles as we had of the potassium tetrachloroaurate. So what I'm going to do is I am going to add 2 molar equivalents of potassium hydroxide solution to this. Now, according to the Handbook of Preparative and Organic Chemistry, gold hydroxide should dissolve in this. I guess we'll see. And, well, it says that we need to heat it up. Guys, hush. It's just somebody playing with fireworks. The textbook says that we need to heat this up, so maybe it's only soluble in warm KOH. I don't know. But it's supposed to react with it, presumably as it dissolves, to form a solution of potassium aurate. Then, after we've got the solution, if indeed this all works out, we have to very carefully evaporate it down in the dark. Why? I don't know. Apparently potassium aurate is not the most stable of things, so that's why I'm becoming a little dubious as to whether this is actually going to work or not. Guess we'll see. Okay, everybody. Well, that was a complete and total failure.
Failed.
But I think I know what happened. I think it got too hot, and I can't confirm this for sure, but it looks to me like it might have broken down into the oxide. Now, I'm not 100% sure on that. It could have broken down into metallic gold, which doesn't look gold when it's coming out of, precipitating out of solution. But this looks very dark to be that. I don't know. It kind of had a purplish tint at first, which made me think that it was nanoscopic gold particles, like purple of Cassius. But I don't think that's what this is, because there are just too many big particles in there. Now, potassium aurate, when it gets too hot, the textbook says it will break down into metallic gold, potassium hydroxide, and either sodium or potassium oxide or peroxide. Any of those would, either one would have reacted immediately with water if it was formed. I doubt it would even have been formed. So that makes me think that they were talking about the solid compound. Now, you do use gold 3 hydroxide to make gold 3 oxide. I don't know, what do you call that? What's the common name for that? Oh, well, gold 3 oxide is what we're going to call it. And so I know that it's supposed to be a dark colored solid. So I think that's what this is. I think I will either went overboard on the heat or the potassium hydroxide or both. And I think it broke down into the oxide. I don't know. What do you guys think? Put that shit in the comments and let me know. That's okay though. I mean, it's not like it can't easily be recovered just by dissolving it in some aqua regia and just adding it to the rest of the gold recycling, which is still evaporating down. Been working on that now for a while. So I guess I'll just go ahead and wrap this up here. I mean, one success, one failure. We'll take it. Kind of cancels out in the end, really. And I mean, it's not really a failure. I just didn't set out to make gold 3 oxide, and I'm not 100% sure that's what this is. However, I will take gold 3 oxide, and I'm about 85-ish to 90-ish% sure that's what that is. So we'll take that instead. So if you guys like that video, give it a thumbs up, and if you didn't, well, whatever. Subscribe, comment, share the video, donate a few bucks if you can. Thank you very, very, very much to everybody who donated last month. You guys really helped a lot. Like, I can't even put it into words. Thank all of you that stepped up and donated to this channel so fucking much, man. It meant the world to me. It really did. Anyway, I will see you guys on the next one. God, that is pretty cool. Yeah, we call that a success. That's not a failure. I keep telling myself that.